What is atomic radius and how it can be affected? When moving across the period, the atomic radius will decrease. But when moving down the group, atomic radius will increase. And why is that? The size or radius of atom is difficult to be defined exactly because the electron cloud has no clear boundary. But we can say that atomic radius is the distance between the two nuclei of a diatomic molecule. So this is the radius of atomic, okay? That is from the center of molecule 1 from the center of molecule 2. So this is the atomic radius. So there are two factors affecting atomic size. First would be CHAP. Second would be the shielding or screening effect. For CHAP, whenever there is a change in CHAP, that is when the number of protons increase, the nuclear charge will increase as well. And this causes the CHAP to increase. When CHAP increases, the attraction between nucleus and outer electrons will become stronger. Hence, the atomic size or radius will decrease. For a change in shielding effect, when the number of shells are an increase, the number of inner electrons increase as well. Okay, remember, when there's more bodyguard, the shielding effect will increase. When this happens, the attraction between nucleus and outer electron will become weaker. Hence, the atomic size or radius will increase. So there are two trends for atomic radius in periodic table, which is going down the group or moving across the period from left to right. So we're gonna discuss about going down a group first. So when going down group 1, the number of shells and inner electron will increase. You can see that when going down the group, the size or the shells become bigger. But the ZAF still remain the same. The ZAF still remain the same with a net positive charge of +1. I explain this is because when going down a group, even though we have the same ZEF, the number of shell or N will increase. So when number of shells increase, okay, so look at when the number of shells increase, the number of inner electron will be increased as well. So this will increase the shielding effect. When shielding effect increases, the attraction between nucleus and outer electron will become weaker. Hence, the atomic size or radius will become larger. So in general, we can say that the atomic radius will increase when going down a group. This is applied for group 1 until group 18. Okay, so you can see clearly that when going down the group, the atomic size will become larger. When moving across the period 3, that is from left to right, the number of shells and inner electrons remain the same, but the ZEF will increase. So what would happen to the atomic radius when moving across the period? Okay, we can explain that the number of shells and inner electrons remain the same, but ZEF or effective nuclear charge increase across the period that is from +1 to +8. Hence, the attraction between nucleus and outer electron will become stronger. When there is a strong attraction, the atomic size or radius will become smaller. In short, atomic radius generally decrease when moving across a period from left to right. You need to mention you are moving from left to right in examination. What about the trend of atomic radius for the first row of transition elements? The variation in atomic radii is less uniform. This is because the atomic size in the first row transition element decrease from Sc to Cr, but later on they will get constant from Mn to Cu. Okay, so we can say that from SC to CR, the atomic size decrease, but from Mn to Cu, the atomic size remain constant. This is because this happens because electron is filled into the inner shell of 3D, but the number of electrons in 4s orbitals remains the same. Hence, the effect of nuclear charge becomes less effective. To summarize the trend of atomic radius, when going down a group, the atomic radius or radii is its plural will increase due to shielding effect. But for moving across period, is from left to right, the atomic radius will decrease due to effective nuclear charge. But for transition element, the atomic radii is not uniform due to the presence of d 3d orbitals. We are not done yet with 3.2, so I'm going to continue with the next lecture.